Hi everybody, welcome to Module 5. In Module 5, we're going to be looking at hypothesis testing, where we compare two means to each other or three or more means to each other. So today we're going to be looking at comparing two means using two different kinds of hypothesis testing. So if we want to compare two means, there's two different possible formats that the data could be in. One is the data could come from unrelated samples, just two separate samples altogether. Or they could come from what's called paired samples or matched samples. Paired or matched samples is when you really have one sample with two observations on each individual. A lot of times that can be before and after, or you can have, like spouses where you've got one measure for each spouse, or siblings or something along those lines. So independent samples is kind of the opposite of paired data. Independent samples are when you don't have matched groups. So I've got some examples. Before we look at that example, let me just show you an example in the data. So we've got two data sets here that we're going to be working with in this lesson. And in this one, we've got, for a bunch of people, we've got their morning temperature in degrees Fahrenheit and their evening temperature. So this would be an example of matched pairs data because we've got person A with two different measures on that same individual. Person B, two different measures on that same individual. All right, so this is matched pairs data. And it may help to think of it as each row of data, within each row of data, this observation corresponds to this observation. Okay, there is a relationship in that, in this case, this observation and this observation both come from the same person. Over here, by contrast, we've got two groups of people who had high cholesterol, and they were assigned, some of them, to eat oatmeal for 3 months, and some were assigned to take a low dose of Lipitor for the same amount of time. And they were looking to see how much their cholesterol decreased over that time period. So there's nothing here that says, this first observation is lined up with this first observation. In fact, these are two completely different individuals. All right, so we've got this group of people taking oatmeal, and this is a completely different sample from the group of people taking Lipitor. So this would be an example of independent samples data, whereas this one over here would be paired. If we look at some other examples I've made up here, is there a difference between people's incomes at 30 and at 35? This would be paired because we've got a bunch of people, and for each of those people, we're going to measure their income at 30 and at 35. So we've got two measures on each person. And then by contrast, if we wanted to see something that was similar but not paired, is there a difference between incomes of business majors and accounting majors? We don't have any matched pairs there. We just have a completely separate group of business majors and accounting majors. Continuing on, we've got two examples here. Do identical twins score the same on a math test as each other? So this would be paired because we've got several sets of identical twins looking at their scores on math tests versus one where we've got independent samples, whether Cuban children score higher on an international math test than Argentinian children. So those are completely separate groups of of individuals. All right? So for this one, let's see if you can figure out which one's which. Do men earn more than women? That's one study. And then another one would be, among mixed gender siblings, does the brother earn more than the sister? So I wish you were here in front of me so I could just ask you. But I will tell you that this first one here is independent samples. Because we're asking, do men earn more than women? Those are just two different groups. Whereas this one here is paired because we've got pairs of siblings. All right? So I will ask you now, I'm going to put one in there for you to try right now, and we'll see how you're getting it. All right, so first let's look at how to do a test where you're comparing means from two independent samples. This is called the independent samples t-test, or sometimes just the two-sample t-test. This is one where we're comparing, you know, the means where you've got the independent samples. Okay, so like these ones that we were looking at up here. So for all of these, you're going to have a group 1 and a group 2. And you need to specify which one is group 1 and which one is group 2. Okay? You'll see what I mean in just a minute. The hypotheses, the alternative hypotheses could be that mu1 is less than mu2, that mu1 is greater than mu2, or that mu1 is not equal to mu2. And if you remember, this one over here, the not equal to case, is called the two-tailed. Okay, so less than or greater than is one-tailed, and then not equal to is the two-tailed. And you're going to need to know this in just a minute for the Excel. I want to mention how this is different from what we've been doing. What we did last week with the one sample z-test and the one sample t-test, the difference there was that we were comparing a mean to a constant. We had some unvarying value that we wanted to compare against. Well, here what we're comparing is two samples to each other. And we want to know, is there enough evidence based on how much difference there is in those two samples to determine that one or the other is greater than the other one, or if there's a difference between them in the population. All right, so here's our example with the oatmeal/Lipitor data. So we've got people who ate oatmeal, people who took Lipitor. By the way, it's nice if the sample sizes are the same, but it's not at all required. In fact, for things like clinical trials, which is kind of what this is, you'll see a lot of people drop out because of, side effects or because they can't stand to eat oatmeal. Yuck. Apples and cinnamon oatmeal's all right, but not regular oatmeal. Anyway, so equal sample sizes is nice, but not required. So in Excel, we're going to use the function t.test. So t.test, and if you hit the FX button, it will prompt you for everything you need. Array 1 just means your first group of data. Array 2 is your second group of data. Tails. Here, let's go back and look at the problem again and see whether this should be one-tailed or two-tailed. whether oatmeal lowers cholesterol more than Lipitor. So this is going to be one-tailed. We're going to set up our hypotheses in just a minute. If they had said, is there a difference between them, then we'd say two-tailed, but this is one-tailed. And for type, you see down here there's 3 options. For the 2-sample test, we're going to use 3. Okay, there is an option to do one where you're assuming equal variances, but I don't want to assume equal variances here. So we're just always going to go with that one. Okay, so for the independent samples t-test, you're always going to use type 3. All right, and I accidentally, it does that sometimes and it drives me crazy. Once you hit the FX button, it puts a plus in there. Anyway, so it's right now, and we get 0.00392 is our p-value. This doesn't give us the test statistic, but that's okay. So let's go ahead and go over here, and we need to set up our hypotheses. So here we've got H0, and we need to specify, before we even write H0, we need to say group 1 equals oatmeal, and group 2 is the people who took Lipitor. So now we're ready to set up our hypotheses. So we've got, for the null hypothesis, you can always leave that as mu1 equals mu2. And the alternative hypothesis is always going to, well, not always. In this case, we're looking whether oatmeal lowers cholesterol more. So whether these values for oatmeal are bigger. Okay. You have to be careful with the phrasing here, because I could have phrased that backwards, and it still would have been greater than. I could have phrased this as determine whether Lipitor lowers cholesterol less than oatmeal, and this still would have been greater than if you set up 1 as oatmeal and 2 as Lipitor. By the way, if you switched your 1 and 2 here, that's totally fine. But that's going to then impact the direction of your inequality if you're doing a one-tailed test. So if you said 1 was Lipitor, 2 is oatmeal, that's fine as long as you put this symbol then as less than. I usually just, for the sake of simplicity, whatever comes first in the description in the problem, I'll put that as group 1. So in Excel, we got our p-value is 0.00392. And let's see what it said for alpha in the problem. It said alpha is 0.05. So we are going to reject H0 if the p-value is less than 0.05. And in this case it is. This p-value is less than 0.05. Therefore, we reject H naught and say that there is sufficient evidence to conclude oatmeal lowers cholesterol more than Lipitor. All right. By the way, I made that data up, so don't use that to give medical advice to anybody. I totally just made that data up. All right, so that's how we do an independent samples t-test. I should point out that every hypothesis test comes with a set of assumptions. And in this class, we're not making that big a deal out of them, but in order for this test to be valid, we should know that both of these two groups are normally distributed, meaning that we should do a histogram on each group and just make sure they're not too far off. If the sample sizes are really large, then it's okay either way. But yeah, I just wanted to point that out. So now let's move to talking about the paired t-test. And the paired t-test is where you've got matched pairs data and we want to compare those means. So here's our example we talked about earlier, where we've got the same 6 people and we've got morning and evening temperatures on both of them, or on all 6 of them. So the way this test works is you actually compute, or the test will compute the differences for each individual pair. Okay, so, and we call those D. So just to show you what that looks like. So D, for this one, we've got morning listed first and then evening. So it's going to be morning minus evening. And so in this case, we've got the morning temperature minus the evening temperature. And then we're just going to copy those all the way down. And if you'll notice, if morning is less than evening, then when we do that subtraction, we're going to get a negative number. If morning is greater than evening, we're going to get a positive number. If morning is equal to evening, we're going to get 0 when we do those differences. So the way this hypothesis test works is it computes those differences and then calculates the mean based on the mean of those differences. So if we look over here, in our hypotheses, we're looking at the population mean mu of all the differences, and that notation is mu D. And then ND is the number of pairs we have. So the null hypothesis is always going to be that there is no difference between these two groups, or between these two measurements. And so the null hypothesis is going to be that mu D equals 0. So there's no difference in the means. The alternative hypothesis could be that mu D is less than 0, mu D is greater than 0, or mu D is not equal to 0. And remember that, just like before, less than or greater than is one-tailed. whereas not equal to is two-tailed. Okay. And just like before, we're gonna need this. So actually, another way you could run the same test, and it would be completely equivalent, is if you were to take these differences and run a one-sample t-test on them, comparing to a hypothesized value of 0. Okay, you don't have to do that because Excel already has this built-in function that will do that. But I do want you to spell out for me which group comes first. So what's X1 and what's X2. Okay, and the reason for that is that it makes a difference which way, if you're doing a one-tailed test, which way the inequality goes. If it's two-tailed, it doesn't matter so much, but for the one-tailed, it does. So let's go back up here and look at our data and see if we can see whether we're doing a one-tailed test or a two-tailed test. So here they're saying, can we conclude that the temperatures are lower in the morning than in the evening? So we're going to calculate our differences as morning minus evening, just because morning comes first. And if temperatures are lower in the morning, then when we subtract that, we're going to be getting a difference of less than 0, so a negative difference. So our null hypothesis is going to be that mu d equals 0, and our alternative hypothesis is that mu d is less than 0. Okay, and that's just because when we do this subtraction, if morning is lower than evening, then when we do morning minus evening, this will be a negative number. Okay. So let's go down here and write our hypotheses again. And we're going to first write that D is calculated as morning minus evening, because I am going to insist that you show me that. And then we've got our null hypothesis, which is that mu d equals 0, and our alternative hypothesis, which is that mu d is less than 0. And in Excel, we're going to use, it's the same function, the t-test function, as we did before. And there we go again with it, doing the subtraction or the adding. So array 1, we're just going to put in our values that are there in our leftmost column. The one where the data is, this one you wouldn't ever want to use. Array 2, the evenings. Tails, this one is one-tailed because it's less than or greater than. And then the type, you can see here where it says paired equals 1. So we're going to use type 1 here. So we click OK, and that's our p-value. Our p-value there is 0.24555. So 0.2456. And let's see, did they give us... They didn't give us an alpha in this problem, but this is one of those where it really doesn't matter because we're going to get the same conclusion regardless. Because our three common levels of alpha, if you remember, are 0.1, 0.05, and 0.01. So let's just go with 0.05 and say that we reject H0 if the p-value is less than 0.05. In this case, that is not less than 0.05, so we are going to fail to reject H0. And say that there is not sufficient evidence to conclude morning temperatures, it's supposed to be morning temperatures, are lower than evening temperatures on average. All right. I should mention that this test has an assumption as well, and that assumption is that the differences follow a normal distribution. But that's okay as long as the, if it doesn't, that's okay as long as you have a large sample size. So if you have a lot of pairs in your data, it's okay. I just want to end this lesson with a few reminders here. One is that I want you to specify which group or measure is which. So for the independent samples t-test, specify that 1 equals business and 2 equals accounting, or that your differences are calculated as before minus after. I am going to be asking you to state the descriptive statistics. So on the independent samples t-test, I'm just going to ask you to compute the mean, the sample standard deviation, and the sample size. So in this one, just the mean, the standard deviation, and the sample size. And you can just see that one is 12. And do that for both groups. And then do the same thing over here. Compute the mean temperature in the morning, the mean temperature in the evening, and then the standard deviations for both groups and the sample size. Also, please remember that when you're using the t-test function, we're never using 2 for anything. We're always using 3 for independent samples and 1 for matched pairs. All right, so that's it for this lesson, and of course, let me know if you have any questions.